questions which he is not able to handle in 1 hour, I will handle those. But the thing is, there's not even a single.
Mic is on. Like I cannot send anyone. The NPTEL team only has the rights to send. Like I am muted there. Okay, here I can mute. fine, no?
Not too small. I'll wait for 11 minutes dot. I'll close.
Someone has left. Huh. The giant DJ left. Holding सब कौन है? Okay. Good evening. Can you hear me? Really? No. Ah, Shivagami, can you hear me now? No, I think people should hear. Like, can you check? Tell again now. Hello, good evening. Can you hear me? Hello. Good evening. Can you hear me? Ah, sorry. I think there is some mic issue. I have joined from my another account. So I have made a small presentation about small like various topics which was covered in week 1. I run through the presentation and then later you can ask any doubts. Okay, there's a okay. Are you able to hear now? Fine then. So I'll speak from this mic only. Sorry again. I'll share my screen now. Okay, hope you can see it. So this week 1 actually talks about as you have gone through, and I think there is a assignment due also by tomorrow, I guess. I'll try to I won't solve the actual assignments, but I will talk along various topics which you can understand and then answer it further also. And I'll also solve the week 0 dry run sessions uh, problems also. So can I proceed? Is it okay? I'll solve the week zeros. Do you have any doubts regarding the week 0 assignments? Which basically you won't be marked, but it's just for your information that how you will be assessed. So let me go to that first topic, which is the first session. There are basically 4 sessions in week 1. One is related to solar geometry. The next one is also related to climate and climate classification, and remaining 2 modules were related to thermal comfort. Thermal comfort in buildings, what is the introduction, what are the factors that are affecting thermal comfort, and the last session was about various thermal comfort models that has been developed and small examples of these developed models. So let me so I think you are able to see this animation. So basically the S has a 23.45 degree tilt, and also it rotates around the sun throughout the year. Basically this animation what you are seeing is like just a single day's evolution where the sun sets and sun rises for one position for particular location. So just try to see this animation, observe it for a while. I'll talk in terms of solstice, like equinox and solstice. Here this line, actual line, that is March 22nd, and also another one is on the other side, it will be September 22nd, 23rd. That will be the equinox, where you will get equal duration of sun, and like the sun will be like for 12 hours and night will be for 12 hours. And when you go to the other extremes during the December time, you will have the least amount of sun exposure for that particular day. On the other case, when you consider this during the June 21st period, that time you will have the maximum amount of solar radiation which you will get. And all these things will come into play for regions which are above the which are on the like northern hemisphere. like whatever region which is above the equator line, that is only will be following this rule. But when you consider the regions which are below the equator line, example Australia, you will have actually the summer period during the December time. I hope you can understand. Like you can switch on your mic and say yes, so that it will be little bit interactive, because since we have just like few people who have joined, it will be more encouraging for me to also like proceed further. And it is also a doubt clearing session, so it will be helpful that if you have any doubts regarding those all four topics covered in the first week, you can ask any doubt in between. I'll be answering it. And if I'm not able to answer currently, I'll come back next week, same time, 6 to 7 p.m. on Tuesday. So I'll be answering on that session also. So please feel free to ask any doubt or type it in the question if you are feeling shy or something. And can you hear me, right? Moving further to this thing, like in southern hemisphere, example for Australia, actually the inter period will be during the June, because due to that 23-degree tilt, I will also want to show another tool. Let me reshare the screen. There is a website called as andrewmarsh.com. You can also look into it for your understanding related to solar geometry and psychometric chart. You can refer it. So this is that website. I hope you can see that website address also. I can share you this in chat also. So you can also like lively, if you want, you can look into it later also. This one, you can adjust the controls. Like you can see on the right bottom, you can adjust various things like time, month of the day, the longitude and the latitude. So this is the latitude. If you want to like imagine, if you want to set something near Delhi, now you drag this longitude and longitude into position. Yeah, so this is somewhere near Delhi, and you can see the actual lat long data in the top left corner. Around the lat long location, the location is 27-degree north and longitude is 76 degree east. That is the thing. So there is also multiple options. Now you are seeing the earth from the sun's view. You can also see in the opposite direction, like how the exposure is like from the sun, like the overall aerial view you will be able to get it. So in this you can clearly see the tilt, like 23-degree tilt here. And let me go to this month handle, and then I'll try to rotate So actually we have selected a location which is like above the equator, which is near to the northern, like which is the northern hemisphere part. And let me show you, this is during the winter time. Like this is December right now currently. During December, now you can like clearly see, right, like the bottom portion, which is like the southern hemisphere, is actually getting direct solar exposure, and the northern hemisphere part you don't have much sunshine. When you consider this Europe and all, you literally have like not much of solar exposure, because due to the 27-degree tilt, the earth is like slightly tilted, and the southern hemisphere will be getting larger exposure of sun. That's why there will be like summer, it will be summer period for Australia. And exactly, if you go to the other side, which is June will be the time where the northern hemisphere will be getting direct solar exposure most of the time. This time you will see the actual exposure in the southern hemisphere is very low. That's how the whole solar geometry functions, and this you have to take into consideration, mainly because you would have also come across the sun path diagram in the later stages of the course. I'll stop sharing. I'll go back to the presentation. So I have prepared some small questions related to like sun path. One is like, which season will have the least possible altitude angle? And which solar angle decides the window building orientation? Like, is it possible you can try guessing it? So let me just move further. Like for the first one, like the least possible latitude angle will be like for winter season, and the next one, it is like the solar angle decides the window or the building orientation. Which angle decides? Basically, latitude angle only decides the orientation of the building or the window. So like as we have seen in the previous that app that I have shown, in that the latitude angle only decides how far the location is from the equator. If the location is above the equator, you will get larger. Example, you take Delhi. When you have the building oriented towards the north-south direction, like example, you have a rectangular building where the longer axis is along the east-west direction. There is no possibility that there will be solar radiation in the northern side. If you have a window on the northern wall in Delhi, you won't have solar radiation, because since the location is such a way that it's above the equator, and then throughout the year you won't have that exposure. But if you come near to the equator, you will have like almost like equal exposure on the east and south direction when throughout the year. This again I can share the screen again. Now we'll look into in the Earth's exposed angle. This blue line actually depicts the direction of the solar radiation. And let me now slide the solar radiation. So you can also see that what will be the altitude and azimuth angle. This information will be displayed on the top left corner. There is one particular portion called as solar information, where you will have the indication of azimuth angle and also the altitude angle. And also you will have all the details related to like what will be the sunset and sunrise timing for that particular day. This particular day is actually 14th March. So here the altitude angle is 52 degrees and the azimuth angle is 138. This you can see, right? So example, let me change this location. I have placed this location somewhere in southern part of India. Now if you see, there will be some few 1 to like 4 months where you will have solar radiation coming from the northern side in this location. This you can like literally see like this yellow line, which is the east-west line. You can see, you take it that line as reference and check the blue color line, which is the solar radiation's angle. Here you can literally see that the sun is coming from the northern side. As you go further towards December, it will be coming from the southern side. This is for the same timing, just for same time. What time it is? The time is 10:30. For 10:30, throughout the year, you can see that variation in the angle. So this particular understanding of solar geometry literally gives you to information how you decide the orientation of the building and also which side you can give openings for the building. So that's how it is helpful. You can use this tool. There are multiple tools. There was one very useful tool called as Ecotech, which has been like discontinued by Autodesk. So you have to look into some other parts. You can I can mention some other, like there is one software called plugin called as Ladybug, which comes along with the Rhinoceros and Grasshopper, that you can utilize it. Further, there are also multiple like just simpler modeling software like SketchUp. Still, you will have all these solar related tools like when is the shadow. You have to just set which lat long it is, particular set. You will be able to visualize it, but you won't get the in-depth details like this. You can still use this tool to do the analysis. There is also particular another tool I want to show you, which is 3D sun path. Here there is an option for you to like literally model and then upload that details in this. If you want to like use this online tool also, you can export the model and still see how it changes over time and seasons for that particular model. This will be useful. There are also multiple tools which is not covered in this session. Further moving on, I will continue to the presentation. Let us look into the topic of solar time. Solar time basically is the like basically how you decide the time from based on lat long. So longitude basically decides the time difference across all the regions. So and India, if particularly, it has a vast longitude range if you consider, but it has used this 82.3 degree east as the reference location, and the time zone is dependent on it. But if you want to like exactly find the how many minutes we are away from the actual GMT time, we can use this particular chart and use the reference angle 82.3 to determine how many minutes we are away from the actual time. Imagine if you are like if the time is like 12 p.m. It would have been explained in the video also. I'll show another example. In Dibrugarh, it would have not been explained. Dibrugarh is actually the longitude is 95 degrees and it is 12, 12.3 12 degrees and 30 minutes away from the actual reference longitude, and it is 12 degree 30 minutes east of the actual longitude. It means that it will be getting sunshine before the time will be earlier. It will get noon also earlier, but exactly how many minutes it's getting that noon time 12 p.m. we can try to calculate. This 12 is basically the actual time based on the reference, and also we'll use one more thing. We have to minus the actual 12 from the multiplication of this 12 degree and 30 minutes. I am marking it in minutes only, so I am considering it as 12.5 degrees, and I am multiplying for every degree change. There will be a difference of 4 minutes, so I am multiplying it by 4, and there is a reduction of 13 minutes also. This we have to refer the chart. Example for January 26th, when you look at the chart, this chart, the x-axis depicts the day number. So Jan 26th actually is 26th day of the year. So for 26th day of the year, example, it comes around here, which if you look at the y-axis, it's actually the correction in minutes. So corresponding to that 26th minute, you can refer it the left y-axis where it is approximately is 13 minutes. You have to minus 13 minutes from this, and finally if you equate it, you will get 37 minutes. So basically Dibrugarh is 37 minutes earlier than the actual Indian Standard Time. Further moving on, what are the factors that are affecting, like I'll speak in terms of solar radiation. Solar radiation, we have two units. One is radiance, which is basically instantaneous flux falling on one area, which is measured in meter square per unit area. What is in terms of watt? What is the instantaneous solar radiation falling? That is irradiance, and irradiation is over time. Over time, what is the total solar radiation? What is the total solar radiation per meter square? That is irradiation. And further moving on, there is a concept called as solar temperature, which actually combines the effect of solar radiation and also the ambient temperature. You would have seen the actual formula. This single number will give the effective one single term, the effect of temperature and also the solar radiation falling, and it is affected by the absorptivity of the surface where the solar radiation is falling. That you have to take into consideration. If you have any doubts, you can ask in between also. And also I also will talk about what are the various factors that are affecting irradiation. One is the angle of incidence of the sun, and next one is the atmospheric depletion, and the third one is the amount of duration of sunshine. So like example, if you take winter case, during winter you will have very low duration of sunshine for that particular day. And further moving on, let us talk about climate classification. There are like multiple climate classifications, and let me first tell about the variables that are associated with climate. One is like temperature, relative humidity, which is analogous to vapor pressure, solar radiation, all these things, and also precipitation. All these things come into factor, and there are multiple classifications, and NBC is the one which is mentioned in National Building Code, which has 5 different classification, which classifies India into like cold, hot, warm and humid, hot and dry, and also composite regions. Further moving on, let me speak about building related considerations, what you have to consider for different regions. Like example, warm and humid, you'll try to implement more of ventilation. So to maximize the ventilation, you try to like space the buildings far apart. You won't go for compact design, and also you will keep a large perimeter to area ratio. But when you consider hot and dry, cold and composite regions, you will go for lower P by A ratio, and also you go for a compact formation. And for hot and dry regions, you will have very hot and dry conditions. It's better to avoid wind that is coming into space, so you try to protect it from wind. And even for cold regions, you will have cold drafts, so you try to protect, which is pretty similar for both regions. And composite, it actually requires a diverse solution. Example, like you try to maximize solar radiation during the winter time because it will be too cold, and during the summer you try to minimize the solar radiation. In that way you have to design. Further moving on, the week one also covers about thermal comfort. There are like what are the it speaks about what are the factors involved in thermal comfort, and what is the comfort zone, and various thermal comfort models. And when you talk about thermal comfort, you can speak in terms of the heat balance equation, thermal sensation, thermal equilibrium, and thermal perception. These all try to explain thermal comfort in different perspective. Like there have been models which are made based on just heat balance equation, and it talks mostly in physiological term. And there are also models which look into physiopsychological way, which is adaptive thermal comfort model, where they measured the environmental parameters across multiple locations, and simultaneously in time they asked people, when they measure the environmental parameters, they also asked people who are living in the building about how they are feeling. So and based on that, they made a statistical analysis and proposed a model, that is adaptive thermal comfort model, and looking into various comfort parameters. There are like environmental parameters, personal and other contributing factors. And let me just try to stop, because like this is more like a small examples solving session and also doubt clearing session. You can like ask some doubts to me. I'll try to immediately reply, or if it is not solvable, I can come back to the next session and reply you also. So I'll stop now. You can like ask any doubt related to this is for the first week. Thank you. You can also type the any doubt, type in chat. Okay. Mhm. If you don't have doubts also, you can just like at least try to introduce yourself. I can like get to know why you are doing this course also. Hi Shreya, like you have just joined, but we have been speaking
Hello.
about. I was just trying to like show some examples and how to approach about during for the first week only. So this session
Okay.
was on just first session. You have any
Okay.
doubt related to the first lecture on which happened during the first week?
Um, yeah, actually, I had one doubt related to how the longitude
Uh-huh.
affects the time
Time, no? Yeah.
affects
I'll go
yeah
back to solar time. This
yeah
this is the one, right? So
yeah that one.
basically, so if you consider India, no, it's like its longitude is it has a range of longitude
Hmm.
from like if you
Okay.
consider like from Gujarat till the northeast till Meghalaya, you will have that large longitude range. But we have one particular only one single time zone, okay,
Okay.
which is like plus 5.5 hours, GMT plus five
Okay.
and a half hours.
Yeah.
Yeah, but when you consider other European countries, no, each country will
Hmm.
have its own time zone.
Okay.
Here, like we just to like not to confuse people of India, they just announced one single time zone using this reference
Yeah.
longitude
Yeah.
82.3.
Hmm.
So, but imagine you are living in some easternmost region, which is
Okay.
Dibruga. Okay, it is part of
Huh.
India and its longitude is 95 degrees east.
Huh.
So you have to minus this 95 degrees from the reference angle, which is 83 and a half.
Okay. Huh.
So after you minus, you will get this 12 and a half degree east angle. Okay.
Yeah. Yes.
Further,
Huh.
one more thing is each longitude angle, no, one each degree,
Hmm.
it accounts to 4 minutes of
4 minutes.
delay.
Yeah.
Okay. So if you want to calculate the exact time for that particular location,
Hmm.
you minus example, we have taken the same reference time,
Yeah.
January 26, 12 o'clock, 12 p.m. Okay. From 12 p.m., you minus it using this actual particular. 12.5 degree east, you convert it into just minutes, 12.5 minutes, and multiply it by 4. And then you utilize this chart which would have been showed in the lecture.
Yes.
From the chart, you actually look at this, which day it is. It is the 26th day of the year. So
Okay.
for the x-axis, what is the exact y value? It's around -13.
Okay. Oh. Okay.
Then you minus it. If you are getting positive, you add plus. Okay.
Okay.
And then you
Understood.
equate it, you will get around you are getting 37 minutes. So
Yeah.
basically that location is actually 37 minutes earlier than, so you will
Yeah.
get before the 37, like before 37 minutes only, that particular location, it would have become noon, 12 p.m.
Okay. Okay.
That's how it is. That's how you solve
Yeah.
it.
Understood. Yeah. Now I understand. Thank you.
Any other doubt you have?
No. No. Nothing else.
Fine. Maybe you tried next time, you try to join before only.
Yeah. Actually, the time was 7 p.m.
Actually,
In
there
my
are
mail.
like two sessions for
Oh.
like
Okay.
two different sessions conducted by two different people. One
Oh.
session will be
Okay.
like 6 to 7. Another session is 7 to 8.
Oh, I didn't know that. Okay. Next time I'll check.
Okay, fine. So you can ask the week one's doubt also next week if you can.
Sure. Yeah.
Okay. Next week also I'll try to make some kind of presentation which has some kind of examples. It won't have the exact assignment, but it will help you to go through assignment if you have any doubts.
Okay. Okay.
Fine then. So I'll close. If you have any other doubt, you can ask. So I'll just try to. I was actually in middle of
Hello, sir,
asking. Yeah,
Vimal
yeah.
here.
Yes, Vimal. Vimal, you can speak. Actually, I can't hear you now.
So
Yeah.
what happens if there is a dark surface increase in solar temperature? Can you hear me?
Can you repeat the question? I was not able to hear clearly.
There is a dark surface.
Uh-huh.
You're not able to
Okay.
hear me?
Yeah, I can hear. I can hear. You are asking that what if the surface is too dark?
Yeah. What if there is a dark surface on a building? What will happen to the solar temperature? Will it increase or decrease?
It will increase because
It
since
will
the
increase. Okay.
it's like
How
proportional
far
to the
can
absorptivity,
you?
right? So since the absorptivity is very high,
Mm,
you will have a higher solar temperature. If you have like a white surface, you have a highly reflective, not white. If you imagine you have an aluminum kind of surface which is like very low absorptivity, your solar temperature will be very less. So further, one more thing is like solar temperature is something that you try to equate like the effect of solar radiation and also the actual air temperature. It will finally further impact the outer surface area of the wall, but what you want is like how the indoor is, if you think in terms of indoor comfort. Solar
So
is a
will
good,
there be a difference in vertical solar temperatures?
it will be. It depends on the shading also, right?
Uh,
If example one surface it's like totally
yeah.
shaded, that also it will be there. But if you just consider a plain wall, I won't say there won't be much vertical difference.
Okay. Okay.
Uh,
Thanks, sir. Thank you.
yeah. And what else? In terms of any doubts related to like adaptive thermal comfort and thermal comfort models that have been made? And one more thing, this globe temperature, like mean radiant temperature is actually dependent on multiple things. Like it depends on all the surfaces around one particular point, and each surface radiant component it takes into account, and then it's a larger formula, but there is one simpler formula called blending formula, where you use this globe temperature probe, and also it depends on the air velocity. If you have like three parameters, the globe temperature, the dry bulb temperature, and also the air velocity, you will get a approximate measure of the mean radiant temperature. So this is the formula. And also, just for reference, like how the perceived environmental temperature will be, you have to take into account both the temperature, which is the dry bulb temperature, and also mean radiant temperature. You have to take into account the both. So there are various findings by different researchers. So this is one of this. And what else I can talk about? In terms of I didn't show another. I want to show another tool. On me go to that tool. Same this andrewmarsh.com website. You can find the tool. This is the psychrometric chart. If you would have listened to that lecture, like it contains this chart contains like data related to one particular point. You will be able to pin down what is the dry bulb temperature, what is the relative humidity, and multiple factors are there. But let me go to one particular location. In example, this here in this case, I have taken the location of Singapore, where you can see that location is warm and humid kind of thing. The whole place is like warm and humid. So the mostly that place requires, based on the given is bioclimatic chart. The range actually it can be. Let me go to this ASHRAE tool, where you can find the band. Like this is based on this PMV model. PMV model is also based on 6 different characters, which is parameters: air temperature, air velocity, mean radiant temperature, clothing level, metabolic rate. So all these factors come into play. And so if you have a change in this clothing level, example, you are here, it is mentioned as one Clovalius one, which is like a business suit, known as a business suit, where you are in like a place like Chennai. Singapore, you can like sometimes it feels like Chennai only. So imagine you have like 0.5 flow value, which is like you can say you are wearing a t-shirt and a loose pant. So you can see, right, the actual comfort burn shifts. So you can use this tool also like to, but it also depends on what model you are choosing. Here, this is EN 15251, which is an international standard. But all this, there are multiple factors that come into play, because this PMB model actually it was based on a field study where like people were made to sit in a one experimental chamber, and then they were applying with votes, and based on that they developed this model. But since it is a controlled environment, and this experiment will happen like around between, like, correct me, it's like around like 18 degrees Celsius till 32 degrees Celsius. But imagine if you have some condition which is like 35 degrees Celsius or 37 degrees Celsius. It was not actually experimented, but this equation still holds good for milder conditions. So the basic use of this chart is you can like put the weather file of particular location, the building you are going to design, and then check what and all strategies can work. Example, if you choose this given is bioclimatic chart, it actually shows what and all strategies also are needed. Example in this, so most part of the year, the building will be comfortable with just natural ventilation, and some fewer parts of the year it requires dehumidification and air conditioning. But if you go to some other location, there will be like multiple strategies that you can try to utilize and then incorporate inside the building. So I think it's like I am going 10 minutes beyond the schedule because like people join late. I'll finish this session at 7:10. Thanks for joining. Try to join at 6 p.m. next week also, coming weeks. It will be happening for the next 3 more weeks. So if you have any doubts for I think can you reply like what this is week 2, right? Currently what's happening for you. So I'll try to solve the doubts for the week 2 next week. So like that till for all weeks, 4 weeks, I'll this session will be there. Okay. Thanks for joining. You can also like
So,
yeah, please.
yeah. So the 7 p.m. to 8 p.m. slot, is it the same session happening again?
It will be conducted by one more scholar.
Oh, okay.
It's for flexibility also it has been created, but it also in terms of
Oh,
content also there will be different content.
oh, okay.
Person
Yeah,
will be,
understand.
if you want you can
Okay.
join that also.
Yeah.
Yeah.
So, students are expected to attend both or either one.
You are expected, you are not it's just for your clearing of doubt and further
Okay.
like if you have something that pinning you are like you are not getting into it, or like it was not explained well in
Okay.
the like it would have been explained well, but if you want to further ask something deep how things work, or like you want some solving that has to happen, this session will be that's what the
Okay.
session is for.
Yeah. Thank you.
Okay. Like can I know like what and all like you people are like doing bachelor's, masters, or
I'm doing bachelor's in architecture.
okay, fine. Vimal, how about you? Fine, then okay, okay. I think it's like you don't have any further doubts for this session. Hope you join the next session. Thanks for joining. Anything else? If not, I'll close the meeting. Thank you.